Hey, what's up, guys? This is Chung here. So let's take quickly look at today's daily challenge problem number 1015. Smallest integer divisible by k. So here's the description. You're given like a positive integer k, and you need to find the length of the positive integer n such that n is divisible by k. And and here's the constraints. So n only contains the digits 1. And return the length of n. If there's no such n, return -1. So now notice that n may not fit in the 64-bit signed integer. So which means that we have integer k here, and the k is in the range of 10 to the power of 5. And it asks us to find if there exists an n such which only consists of one that is divisible by k. So basically 1, 1, 1, 1, 1, 1, 1, 1, 1, right? So on, continue until it reaches the length of, until it can be increasing forever, right? So and how to solve it, right? Mm, so I think here we need to make some observations. The first observation is like this. Let's say we just starting from one, assuming we start from one, and then we go from one one the brute force way, right? One 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 and one 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 one. How many times we need to repeat these things? I mean, we should at least, at most repeat this k times to either find this n here or return -1. And why is that? Because, so divisible by k means that if we do a modular, if we have an n here, right? If we do an n modular by k, if this thing is 0, then we know, okay, the n is our answer, right? But with k, how many possible modulars we have for k? Of course, it's from 0 to k-1, right? So that's the total possible modular after doing the mod k, right? That's why within this range, if we haven't seen that the zeros, then it means that, okay, it will never find an n here, because as long as we see a duplicated modular here, it means that if we continue doing this kind of modular, the mod k, and then we increase the n, we increase one digit by n, the modular will end up in the while, in the loop, so that it will just continue in that loop forever and ever, and will never find the zero. So the first thing is that the for loop, we only need to do a for loop for this many of times, basically k times. And then the second one is the what? And the second one is this constraints here. So I mean, keep in mind that the k could be pretty huge, right? And if we're doing this kind of brute force way by increasing this n by increase times this n by 10 every time, right? And then plus one, this n number will definitely overflow, because the biggest number is going to be 10 to the power of k, right? So, and if k is like this big, this number will definitely overflow. So we need to find a way to to solve it, right? So how can we solve it? So the way we solve it, we should use the remainder, not the n itself. So why the remainder can represent n, right? So let's say, for example, we have let's say the k is 3, okay, and then we start from 1, right? Start from 1, then the 1 divided by 3 equals to 1, right? And then we do a what? We do a 1. Now it's 11. 11 divided by 3 equals to 2. Actually, let's not use 3. Let's use 4. I think 4 is better. So let's say we do a 4 here. It's 1 and 11 divided by do a modular by 4 is what? It's by is 3. Yeah. And then 111 modular by 4 is what? It's also it's also 3. Yeah, because this is and that's why so why is 111 can represent it by 3? So we're saying that we're going to use this 3 to represent this 111 because this here let's say we have 111 to modular by 4 is this is also 3. So why this thing works, right? Because the if we do this 111 is equal to what? Is equal to 27 times 3 plus 3, right? And then this thing will do a plus 10 times 10 and then plus 1. Okay. So as you guys can see, so this part, since this one, the previous one is always like times the k and then plus the plus the remainder. So whatever before this plus sign is divisible by k, right? So it means that after times 10, the total result is also divisible by k. So which means that we can ignore this part. We can ignore this part and we only consider the remainder part and times 10 plus 1. That's why every time we can, instead of using this big number, right, that keeps increasing, we can always use the remainder and then to represent the last number. Okay, cool. So if we have figured out those two things, now the rest part is pretty straightforward. Basically we have a remainder n equals to 0, and we have a scene dot remainder. I'm going to keep all the scene remainder in the set, right? And like I said, we just need to loop through the k times, right? And then the remainder, right? So the remainder is like this. The remainder is a remainder times 10 plus 1, right? And then we do a divided by k. Since we use the remainder to represent the n here, that's why every time when we will be updating the remainder by doing multiply 10 and then plus 1 and divide by k, right? So a few things. If the remainder is equal to 0, okay, of course we know we simply return I. I think I need to return I plus 1 because I is 0 based, and we need to return the length, right? The length is 1 based, or we can do a 1 to k plus 1, but since I already used I here, I'm going to stick with it. So that's that, right? I mean, the second one is what? So the second one is if the remainder is in the scene, right? Then we simply return -1. And in the end, we add this remainder to the scene set, right? And then that's it. We don't even need to return anything here because we know we'll definitely find a result, either this one or the -1 within this k for loop here. And let's try to run the code here. All right, accept it, submit. All right, cool. So that's that, right? I mean, the time complexity, of course, is the length of is k, so O of k, and the space is O of k as well. And yeah, I think I think that's it for this problem. Okay, I'm going to give it my own upvote since this one already got too many downvotes. All right, cool guys. Thank you so much for watching this video and stay tuned. See you guys soon. Bye bye.